So what's the real difference between a generic AI and one that's actually, helpful? Today, we're going to pull back the curtain and look at the art of turning a raw, basic AI into something truly special, like a refined masterpiece.
I mean, you've probably wondered this yourself, right? Why is it that some AIs are super helpful and others just aren't? They completely miss the point. Well, the secret isn't magic. It's all about a really meticulous process called fine-tuning.
Okay, so this slide shows the difference perfectly. On the left, you've got a base model. It's really just a next word predictor. So when you ask it to write an article about the moon, it just assumes you're giving it examples of prompts and writes another one. But look at the fine-tuned model on the right. It actually understands your instruction. It gives you an answer, not just a completion. So how do we get from that clueless model on the left to the helpful one on the right? Let's unpack that.
All right, here's our game plan. Think of it like we're in an AI sculptor studio. We're going to start with the raw material, then make our first big chisel cuts to teach it how to follow instructions. After that, we'll refine our technique, add the final polish with human feedback, and then at the very end, we'll figure out how to judge the masterpiece we've created.
First things first, every great sculpture has to start with a block of stone, right? For a large language model, that raw material is what we call a base model.
And this raw block of marble analogy is just perfect. This base model has basically vacuumed up a huge chunk of the internet. So it understands grammar, it knows facts, but it's completely formless. It has all this potential, but absolutely no purpose. It literally doesn't even know it's supposed to be helpful.
So the journey from that raw block to a polished assistant really breaks down into 3 key stages. Step 1 is pretraining. That's where the model gets all its raw knowledge. Then comes step 2, supervised fine-tuning, where we teach it to actually follow instructions. And finally, step 3 is preference tuning, which is all about aligning it with what we humans find helpful and, safe.
All right, so let's pick up our tools. It's time to make those first, really important cuts into our block of marble. This is the part where we start to give it some real shape and purpose.
This first big step is called supervised fine-tuning, or SFT for short. And honestly, the core idea is pretty simple. All we do is show the model thousands and thousands of high-quality examples of an instruction and the perfect response. It's kind of like a massive flashcard session for an AI, just teaching it over and over again. When someone asks this, you do that. And this is the process that carves out that basic form. The model is no longer just a mindless language predictor. Now, it's starting to look like an actual instruction-following assistant. Now, it's not perfect yet, not by a long shot, but that fundamental shape is finally there.
Okay, we've got the basic shape down, but now we need to refine our technique, because that first method, while powerful, is also super inefficient. It's time to start working smarter, not harder.
So here's the big problem with that first approach, which is called full fine-tuning. These models have billions of parameters. You can think of them like tiny little knobs and dials that control everything. Trying to adjust every single one of them takes an absolutely astronomical amount of time, computing power, and money. For most people, it's just not practical at all.
And this is where a really clever method called parameter-efficient fine-tuning, or PEFT, comes into play. One of the most popular techniques here is called LoRA. The idea is brilliant. Instead of recarving the entire statue, LoRA lets us freeze the original and just train a few small new pieces that we add on top.
It's actually surprisingly simple how it works. Step 1, you take that giant original model and you freeze it. Lock it down so nothing changes. Step 2, you add these tiny, new trainable layers, called adapters. And here's the crucial part. Step 3, you only train those small adapters. That means you're updating just a tiny fraction of the total parameters, which makes the whole process dramatically faster and cheaper.
And this is why it matters so much. Techniques like LoRA are basically democratizing AI. It means that a small team, a university researcher, or even just a hobbyist, can now take one of these super powerful base models and fine-tune it for a very specific purpose. Like analyzing medical texts or writing code without needing a giant supercomputer. This is a really big deal. So, our sculpture has its shape and we've even refined our tools, but it's still a little rough around the edges. Now it's time for that final detailed polish, the part that's going to truly bring it to life and make it something people actually want to interact with. And to do this, we have to teach the AI what we humans actually find helpful. We do that with something called a preference dataset. So for any given prompt, like what is an LLM, we show it 2 different responses. One is kind of lame and unhelpful, and the other one is detailed and just better. We're literally just telling the AI, hey, be more like the good one, not the bad one.
Now, this process is actually fascinating. First, a bunch of humans go through and create all this preference data by just picking the better of two responses, over and over. Then, we train a second AI, called a reward model, on all that data. Its only job is to become an automated judge that can predict which response a human would prefer. And finally, we take our main LLM and fine-tune it to generate answers that get the highest possible score from that AI judge.
And this preference tuning, that's the delicate final touch on our sculpture. This is the sanding and the polishing. It's what adds the nuance, the expression, and the alignment that makes the final piece impressive, helpful, and most importantly, safe for everyone to interact with.
Okay, so we finished our sculpture, it looks great, but how do we actually quantify that? How do we measure if one AI sculpture is objectively better than another one? That's the next challenge.
Because after all this work, how do we really know if the sculpture is any good? I mean, good can be pretty subjective, right? Does it mean it's factually accurate or creative? Well, let's see how the experts try to measure the stuff. Well, one of the main ways is with standardized tests, which we call benchmarks. It's just like how students take exams. We test these AIs on their general knowledge using something called MMLU, on their math skills with GSM-8K, and even their coding abilities with HumanEval. This gives us some hard, objective scores we can use to compare them.
But, and this is a big but, there's a catch. Getting high scores on these tests is great, but it isn't everything. The real gold standard, the ultimate test, is still just human evaluation. Do real people actually prefer to interact with it? Does it feel helpful? Is it pleasant to talk to? At the end of the day, the user's experience is what really matters.
And this leads us to a really famous idea known as Goodhart's Law. It basically says that when a measure becomes a target, it stops being a good measure. In other words, if you focus only on getting a high score on a test, you'll find ways to game that test, often at the expense of overall quality. You might end up with a model that's amazing at math problems, but has become totally useless for a normal conversation.
And so that leaves us with one final big question. This whole process, from the raw block of marble to the final polish, is really just a series of human choices. And as we all become the sculptors of this incredible technology, we have to keep asking ourselves, what kind of art do we actually want to create for the world?